Hi, my name is Matt Parr, and this is the audio abstract for the paper Effect of a Gluteal Activation Warm-up on Explosive Exercise Performance. I decided to investigate the commonly used warm-up modality of activation exercises. I had seen this used increasingly in the environments I had been in. Activation exercises are believed to increase the recruitment of the specific musculature activated, with particular focus in this case on the gluteal musculature. There are two reasons for gluteal activation. Firstly, to improve movement kinematics, and secondly, to increase performance outcomes such as ground reaction force provided from hip extension. The focus on activation of the gluteals is due to their impact on many sporting actions via explosive hip extension. Also, their use in therapeutic exercise, glute activation has been used to treat ailments such as lower back pain and anterior knee pain. As the explosive exercise modality, I chose the hang high pull, as this is an explosive hip extension which is easy to execute at relatively high loads. The purpose of this study was thus to combine kinetic and kinematic measures to provide a global picture of the effect of gluteal activation on explosive exercise performance. The experiment utilised professional rugby players to complete the study. All players completed the experiment during their midweek day off and thus were at similar states of readiness. The experiment followed the following procedure. On arrival, subjects had surface EMG electrodes and Vicon reflective markers attached and secured. Then undertook a control warm-up which had a general preparation focus with no specific gluteal activation involved. Following this, they had a 1 minute rest, and then performed 3 hang high pulls at 80% 1RM. These high pulls were performed on a force platform within the Vicon motion capture area, simultaneously collected EMG data. Following this, they undertook a 20-minute rest period. This rest period was to allow any potentiation from the control warm-up and hang high pulls to wash out prior to the gluteal activation warm-up. Following the 20-minute stand down, subjects performed a gluteal activation warm-up, which was a modified general prep warm-up with the addition of gluteal activation exercises. These were chosen for their high percentage of MVIC. Just to note, both warm-ups were work matched. Following this gluteal activation warm-up, a further 1 minute rest was taken. Then the subjects undertook 3 more hang high pulls at 80% 1RM. A further 20-minute rest period was taken prior to conducting MVC testing. Kinematic and kinetic data was collected simultaneously during the hang high pull. Kinematic data was collected using an 11-camera Vicon motion capture system with 18 reflective markers utilised for the musculoskeletal model. This data, in conjunction with the kinetic data from a force plate, was synchronized and combined into the previously stated musculoskeletal model free body beta. This allowed us to estimate muscle forces of the right lower limb. Free body beta offers a unique insight to estimate muscle forces. It utilizes reflective markers to locate and orientate a 3D linked chain of 5 sequences. The foot, calf, thigh, patella, and pelvis are used to calculate lower limb geometry and in turn calculate muscle forces and torques. EMG amplitude was collected, rectified, and smoothed, then normalized against the previously collected MVCs. The major findings of this study were no differences in ground reaction force were found between control and activation groups during their hang high pull. A non-statistically significant increase in hip external rotation following the activation warm-up was found. A non-statistically significant increase in estimated muscle forces during the hang high pull following the activation warm-up was found. However, there was a strong trend for increased muscle force, in particular the bilateral hamstrings and the gluteus maximus. Contrastingly, there was a trend for mean peak gluteus maximus and gluteus medius EMG activity to reduce during the hang high pull following the activation warm-up. This decrease became significant for the gluteus maximus when the whole cohort was considered, and significant for the gluteus medius when the free body beta cohort was calculated. The trend of increased muscle forces in the bilateral hamstrings and gluteus maximus and increased hip external rotation are in line with the clinical consensus. When considering these results holistically, they suggest that a gluteal activation warm-up can alter the relative musculature involvement in an activity and have a positive impact on lower limb posture. An unusual finding in this research is that there was a statistically significant decrease in gluteal EMG signal after the gluteal activation warm-up. No change in ground reaction force, and a trend for estimated muscle forces to increase following the gluteal activation warm-up. Two reasons for this may be: firstly, altered kinematics that may facilitate the glutes to operate in a more optimal position on the length tension curve, potentially allowing the same level of neural drive to generate greater muscle force. Secondly, the gluteal activation warm-up potentiated the glutes to contract to a greater extent despite being given the same neural drive. This has been hypothesized to be due to the corticomotor excitability and improved ability of the neuromuscular system to recruit the affected musculature post-activation. Some limitations of this research are that the findings are based on the interpretations of our results. These EMG and estimated muscle forces could also be explained by error. However, no change in ground reaction force with decreased EMG signal makes this seem unlikely. So the final take-home message would be: glute activation may be a good method of acutely recruiting the hamstrings and glutes, potentially resulting in improved movement quality. Finally, these results imply that increased recruitment may be due to a potentiation of the neuromuscular system, causing a given level of neural drive to evoke greater force production. That has been my audio abstract of the paper, Effect of a Gluteal Activation Warm-up on Explosive Exercise Performance. Thanks for listening. I hope you found the paper interesting. The paper is available open access at BMJ Open Sport and Exercise Medicine. Alternatively, a link is pinned to my Twitter page at MattyTPar. If you wish to contact me about this or anything else, please use my